Hello, this is Mr. Stein, and in this video, I'm going to show you how we can represent relations in math class. At the end of this section, you should be able to define and give examples of relations, represent a relation in 6 ways, classify a relation as one-to-one, one-to-many, or many-to-one, and identify the domain and range of a relation. So first, we're going to need to define a relation, and then we're going to look at 2 examples. We're going to represent those 2 examples in 6 different ways. So what is a relation? A relation is just the way that 2 sets of things are connected together. It's the way that 2 sets of objects, numbers, or things are connected together. It's a very general statement. And as we look at some examples, it'll become clearer what I mean about sets of objects being connected together. So we're going to do 2 relations. We're going to represent them in 6 ways. The first relation that we're going to do is we are going to relate an animal with the number of legs it has. So this is a relationship between animals and numbers. And our second relation, we're going to relate a number with the triple of the number. All right, so let's take a look at number 1, that first relation. We're relating animals with the number of legs it has. We're going to represent that relation in 6 ways, and then we'll do the same thing with number 2. So our first way is a table of values. This is a t-chart. So on one side, I'm going to write animal. The other side, number of legs. So I'm going to choose some simple animals. Dog has 4 legs. Cat has 4 legs. Spider has 8 legs. And lastly, a hen has 2 legs. There's our table of values. Our domain values are on the left side of the table, and our range values are on the right. We choose the domain values, and then we get our range values from the domain. So we choose the animal dog, and then our relation tells us that the dog has to relate to the number 4, because that's how many legs it has. So that is a table of values. An arrow diagram. So we draw a circle for our first set, and these will be our animals. And a circle for our range values. This is the number of legs. So we have dog, cat, spider, and a hen. 4, 8, and 2. Now notice in my table of values I have dog to 4 and cat to 4 as well, but they're different lines. So you'll notice here that goes to that 4 and that goes to that 4. But in our arrow diagrams, the dog goes to a 4 and the cat goes to the same 4. Then we connect the spider to 8 and the hen to 2. Right, so this again is our relation, an animal with the number of legs it has. Now we're going to do a set of ordered pairs. So a set is indicated by squiggly braces. And then an ordered pair has our domain value first, dog, goes with 4 legs. That is the ordered pair for dog. Cat goes to 4 legs as well. That's the ordered pair for cat. Spider goes to 8. And lastly, a hen goes to 2. All right, graph. Now we could graph this. Just quickly, I'm going to do a really quick, not fully appropriate graph for school. 2, 4, 6, 8, and then dog, cat, spider, hen. And the dog has 4 legs. It's just a bar to 4. The cat has a bar to 4. The spider has a bar that goes up to 8. And the hen has a bar that goes to 2. It's not appropriate for school because I'm omitting the proper titling and whatnot. But this is the number of legs. What's important about the graph is the range values always go vertically. The domain values always go horizontally. In our ordered pairs, the domain value is first and the range value is second. Now, equation. I cannot do an equation for this. There is no equation that relates the animal to how many legs it has. So this one has no equation. Words. Well, we've already written this relation down in words, and that is up here. Relate an animal with the number of legs it has. Or we can write it this way. You start with an animal. So start with an animal. An animal has this many legs. Notice how I put the domain value first, the animal, and it has this many legs. That is the range value. Okay, so that is our first relation. Now our second relation, number 2, is relate a number with the triple of that number. So I'm going to build a T-chart to build a table of values. So here's our number, and here's the triple of that number. So I'm just going to do 0, 1, and 2. 0. 3 times 0 is still 0. 1 times 3 is 3. 2 times 3 is 6. So there's my table of values. My first column is our domain. My second column is my range. Now I could choose more numbers to go in this relation. In fact, all the numbers can go in this relation. But for the sake of time and writing space, we're only going to choose 3. Now we're going to do an arrow diagram for this. So here's our number. And then on this side, it's going to be the triple. 0, 1, 2, 0, 3, 6. 0 goes to 0. 1 goes to 3. 2 goes to 6. Now we're going to write this as a set of ordered pairs. Remember, my domain value goes first, so 0, 0. Then my second value is 1 in my domain, goes to 3 in my range, and then 2 in my domain goes to 6 in my range. And those are the 3 pieces of value that I have. Right, now we're going to graph these. Now for this graph, we're not going to do a bar graph. We are going to do a regular XY graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Our first point is at 0 and 0. Then we go at 1 and 3. And then we go to 2 and 6. That is the graph of this relation. Now, in this relation, because I've explicitly stated that it only has 3 values in the domain, I only plot those 3 values. I do not put a line between them, because I said the domain is only 0, 1, and 2. Now, this one does have an equation. So we take the equation for this one, be our range value is equal to 3 times our domain value. X is used for domains, and Y is used for ranges. So I take a domain value like like 0, put it in for X, 3 times 0 is 0, and that's my new range value. And in words, we start with a number. And then we write out its triple. Okay, so you should be able to take a relation, like we have these two relations here, and represent them in the 6 ways, if it's possible. Table of values, arrow diagram, set of ordered pairs, graph, equation, and words. Right, now we're going to look at different types of relations. We're going to look at one-to-one relations, one-to-many relations, and many-to-one relations. The first word is our domain, and the second word is our range. So a one-to-one relation, one item in the domain goes to one item in the range, exactly for every one. This is like our triple relation. It's very easy to see if we do the arrow diagram. 2 goes to 0, 3, 6. Right, this was our number, and this is our triple. You can see that if I take one item in the domain, it goes to exactly one item in the range. One item in the domain goes to exactly one item in the range. And that has to be true for every element of the domain. Next one, we're going to do the many-to-one relation, because that was like our other one. We had our animals. We had the number of legs. We had cat, dog, spider, hen. We had 2, 4, and 8. So cat goes to 4, dog goes to 4, spider goes to 8, hen goes to 2. Now you can see here we have many in the domain. Cat and dog, many. Many just means more than one. Any number more than one. Many going to 1. So both cat and dog go to 1. So we have this is a many-to-one relation. Many items in the domain go to one item in the range. Many just means more than one. So many items in the domain go to one item in the range. And this only has to happen once. So as you can see, we have the cat and the dog both going to one item in the range. The spider goes to the 8 and the hen goes to the 2. So it doesn't matter what these other ones are doing. As long as we have one instance where many items in the domain go to one item in the range. So what is a one-to-many relation? Well, this would be one item in the domain goes to many items in the range. So what would be an example of this? Well, we're going to do an example here. Arrow diagrams are often the easiest ones to figure out this. We're going to take a person and their kids. So we got a person named Charles. There's 3 people there. Charles goes to 3 kids. So here we have one item in the domain going to 3 different items in the range. Now I was lazy, I didn't list my whole family here, but there's 3 more. But for sake of time, I only did 3. So one item in the domain goes to 3 items in the range. Now you can have a many-to-many relation as well, where many items in the domain go to many items in the range. It gets very confusing, but these are the ones you need to know. So let's write a few notes about the domain values. The domain values are to the left. They're also chosen. We call them the independent variable. It's also our x values. They're also the ones on the horizontal line of the graph. Whereas our range values are usually on the right. Well, they're always on the right. They are dependent on the relation. So we choose our domain value, and that chosen domain value will give us a certain range depending on what our relation is. We don't choose the range value and then the relation tells us what the domain value is. We choose the domain value. Then the relation will tell us what the range value will be. We call these our dependent variable. It is usually our y value, and it is the vertical line on the graph. All right, so after looking at those 2 examples, you should be able to define and give examples of a relation, represent relations in 6 ways, know that some relations cannot be represented by an equation, and for some relations it's tough to do a graph. You should be able to classify a relation as one-to-one, one item in the domain to one item in the range, one-to-many, where one item in the domain can go to many items in the range, or many-to-one, where many items in the domain can go to one item in the range. You should be able to identify the domain and range of a relation. The domain is on the left-hand side and the range is on the right. All right, if you have any questions,